Hi everyone, welcome to another lesson on sequences. Today we're going to look at something called recursive sequences, and to be quite honest, it's just a posh phrase for term-to-term rule. So we're basically just reinventing the wheel a little bit today, but we're trying to take our notation to the next level, make it a bit more mature, and just write things out slightly more mathematically. So let's get going. So if I had some sequence, let's think of a linear sequence for argument's sake. Let's go for 1. Let's not use 1 actually, just in case it causes confusion. 3, 8, 13, 18, 23, ... just as it keeps going and going and going. So obviously this is a linear sequence, it's going up in 5s. The term-to-term rule, we would say, is to add 5 each time. And remember, the term-to-term rule gets you from one term to the next. We would say it's add 5. So we're going to just have a look at making this a bit neater mathematically. So what we're going to say is we're going to call each of these a term, and we're going to write that by saying this is the first term, and we call it t for term, 1. This 8 is the second term, so we're going to call it t for term, 2. And t3, t4, and t5. And then we'd say ... And then we think about some term in the future, we would call it tn. Okay? So it'd be tn. And if you think back to the start of your chapter here, you were looking at a sequence like this and coming up with an nth term rule. So the nth term rule for this sequence, well, it goes up in 5s, so it's a 5n. And you need to take away 2 to get the times table back to the sequence. So we've got all of our terms here. We've got our first term, our second term, our third term, and the blue numbers underneath are the actual value of those terms. And then the nth term of our formula is 5n take away 2. So just before we go any further, I'd like you guys to just think about how I'd label the next term if I had to. So this term's tn. Don't worry about this bit here. Don't need to worry about that line. But what would I write here if I was going to say the next term? So just have a quick think. So the next term, well, let's think about what happens. This first one here is, oops, daisy, term 1, then term 2, then term 3. I'm adding 1 every time. So if I add 1 to this one here, then that would be as simple as tn plus 1. That's just the next term. That probably doesn't sound very illuminating at the moment, but it's going to be useful for us in a sec when we start to think about term-to-term rules. Okay, so just before we go on to what we're really trying to do today, can you, for this sequence, can you define the term-to-term rule for me, please? Okay, the term-to-term rule. Just pause the video and write that down. So hopefully you've said first term is 5. And you need to add 5 every time. Okay, so first term's 5, that's wrong. First term's 3, I can't read. First term's 3, and you need to add 5 every time. Okay, so this here seems a little bit clunky of how to write it down. It doesn't feel very mathematical, so that's what we want to try and do. So we want to say, okay, how can I write this term-to-term rule using this tn business stuff up here? Well, I could say if I have a term, let's call it tn, and if I add 5 to it, then what I get is the next term. tnth term on one, I'm adding 5 to it. And remember, if I want the next term after tn, it's tn plus 1. So this section here, altogether, is essentially this bit here. It's just more mathematical. It's saying if I take a term and add 5, I get the next term. However, I haven't dealt with this bit. First term's 3. So what I need to do is afterwards I need to put a comma and then say T1, in other words the first term, is 3. So there's those two parts there written in a more mathematically mature language, and these are called recursive formulae. I'm not sure why I wrote recursive sequences at the top now. Actually, I think it's because of I think it's just because that's what the title in the book is. These would be the recursive formulae for a sequence. Okay, so let's have a look at an example of this and see if we can get this sorted in our heads. So it says write the first 5 terms of each of these sequences. Okay, so I'm going to do the first one. Can you guys have a go at the second one? So, if you want to have a go at the first one, pause the video. I'm going to crack on anyway. So the first one says tn plus 1 equals tn plus 8. Well, that means that if I take a term and add 8 to it, I get the next term. And this bit tells me that the first term is 3. So the first term's 3, and I need to add 8 to get to the next term, so I get 11, and then 19, and then 27, and then 35. And I'm assuming I can add 8, and that's fine. It looks fine from here. Okay, so that was relatively straightforward. Can you guys pause the video quickly and have a go at B? So for the second sequence, this bit of it here tells us that the first term is 1, T1 is 1. And this bit here says to get to the next term, we have to times the previous term by 2. So 1 times 2 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16. So just before we move on, can you just classify those two different sequences for me? Are they are they linear or are they geometric? So hopefully you've said the first one is a linear sequence because it goes up a constant amount, it goes up 8 every time. And the second one is a geometric sequence. It's got this constant multiple of 2 happening. You're multiplying each term by 2 every time. So that was a geometric one. So these recursive formulas, you can use them for geometric sequences, or you can use them for linear sequences. Okay, what I'd like you guys to do is have a quick go at questions 1 to 4. Again, I wouldn't take any longer than 20 minutes on this. And once you've had a go at those, come back to the video and we'll have a look at one last example and then try the problem solving bits out. If you're struggling with that first question 1A, come back to the video after you've had a go and I'll go through it now. Okay, so pause the video please, and if you want to have a go at that first question, I'm doing it now. Okay, so if you're really stuck with 1A, then you would go about it by saying, well, T1 is equal to 2, so I'm going to write down 2 first, and then I'm going to read my formula. It says Tn, so the previous term, plus 1 gives me the next term. So I just need to add 1 every time. So 2, 3, 4, 5, 6. And it says the first 5 terms of the sequence. So that's more than fine for that one. Okay, so this question is just a word variety of the sequences questions. It says a pond contains frogs and lily pads each month for a year. The number of frogs is given by this. The number of lily pads is given by this one. At the start of the year there are 8 frogs and 4 lily pads. Write the sequence of the number of A, frogs for the first 6 months, and B, lily pads for the first 6 months. So there's a few things to do here. It's just making sure that you understand what it's on about. It's saying find the sequence for frogs. So let's do that first for part A. So in order to write a sequence out, we need the rule, and we know the rule for frogs is Tn plus 1 equals to Tn plus 20. And also, if we look at the question, it says at the start of the year there are 8 frogs. So we also know that T1 is equal to 8. Now, this isn't the answer to the question. It says write the sequence out. It doesn't say write the rule. But just if I get those two pieces of information together in front of me, suddenly this isn't a worded question anymore. It's just the questions you've been doing in questions 1 to 4. So I can now write that out. I can say, okay, so it was 8 at first, and then I have to add 20 on to get to the next term, and I just have to keep adding 20 on each time. Okay, so then we can have a look at part B. In part B, we do something very similar. We are saying we need to do a sequence of lily pads. We can see here what the rule is, and we can see here what T1 is. So we can write that out. Just so we've got it in front of us, Tn plus 1, so the next term of the sequence is the current term, oops-a-daisy, I forgot the 2. 2 times the current term. It would help if I could write, wouldn't it? Let's try this again. 2 times Tn, take away 3. Notice I've stuck in that multiplication sign in. Here there isn't a multiplication sign, but remember when we're doing maths, we write a number next to something like an x. So like 2x, 2x just means 2 times x, or 2a means 2 times a. 2tn just means 2 lots of tn. That's simple as that. Okay, so we know that's true, and we also know that T1 is 4. And so we can write this out. The sequence starts with 4. Then I need to times it by 2 and then take away 3. 4 times 2 is 8, take away 3 is 5. 5 times 2 is 10, take away 3 is 7. 2 times 7 is 14, take away 3 is 11. And 2 times 11 is 22, take away 3 is 19. And that's enough of them, isn't it? It was just, oh, it said for 6 months. I'm being a silly Billy. So this should be 108, and this one should be 35. Okay, so just have a quick look at the exercises. Exercise 13D, question 5 to 7, please. And if you are struggling with that first question, question 5, can you come back to the video, please? And if you don't come back to the video for anything, then have a nice day, and I'll speak to you again soon. Okay, so for question 5a, we're talking about Zachary and his savings account. Bank gives him £3 interest every month. It doesn't matter how much money he has in the bank, it just always gives him £3 a month. 3a says write a rule for this sequence using a recursive formula. Okay, so first of all, we know that the first term of the sequence is 300, so we can write that down straight away. It says Zachary starts up savings accounts with 300. At the end of each month, he records the amount in pounds and sterling in his account. 303, 306, 309. So what we can say is, in fact, actually, let's just change this. I can imagine the answer in the back is actually 303. As you can see in your textbook, it starts 303, so I think that's probably what they mean. Never mind, let's leave it as 303 for now. I think that's probably more likely what they mean. And so that's what our first term is, and we also need to say what the recursive formula is. So we say, okay, well, the next term is my current term plus 3, because it goes up by 3 every time. Okay, this next example, this next bit is about Sadie. Hers also, she also has £300 at the start. However, her recursive formula is different. Her recursive formula is Tn plus 1 is equal to 1.01 TN, which looks like a slightly strange number at the start. Hopefully in years to come you'll see that that's quite a standard one. Okay, so let's just think about it from the end of the first month onwards. So if we do a 1.01 times 300, our first term is 303. So the same as last time. And if I times that by 1.01, I get 306.03. If I times that by 1.01, I get 309.09. I'm just going to leave it as 09 because we're talking about money here. I'm not going to write the rest of the stuff on my calculator. The next one is 312.18. And the last one is 315.30. Okay, so they're the first 5 months there, and it says who has the most money after 5 months, Zachary or Sadie. And hopefully you can see that if we think about Zachary's goes 303, 306, 309, 312 and 315. So Sadie has a small amount more, she has 30p more. Because it says who has the most money, we must actually write down the name. So Sadie has the most money, or Sadie has 30p more. Just a quick note on this. So this first type of interest here, for this question here, is called simple interest. Banks do not use simple interest because it's just ridiculous. If you think about it, they're saying they give you £3 interest every month. But if you think about if you that over years, in a few years' time, you'd have quite a lot more money than £300. Would you still be happy with £3 interest every month? I think the answer is probably no. Whereas this one here is something called compound interest, and compound interest is used in interest rates in banks. It's also it's used for mortgages. So your parents, if they have a mortgage, the way that the interest is charged on their mortgage, it will be compounded. So it's called compound interest or compound percentages. And compound interest is a really powerful thing. Basically, if you have lots of money to start with, then your money keeps growing and growing exponentially, essentially. It just gets bigger and bigger and bigger because every time it compounds is a percentage of what you have, and if you have a large amount to start with, you also get a large amount next time as well, an even larger amount. Okay, so hopefully that's sorted. Like I said previously, if you have any issues, please contact your own teacher, not me, because I'll be flooded with emails. I hope the rest of these questions go well. Have a lovely day, and I'll speak to you again next week. Thanks very much. Bye-bye.